in this single problem, we will solve 5 questions. In this question, we will apply kinematics equations. We will apply the free body diagram to solve this question. We will find out acceleration of this block. We have to calculate the velocity at this point. We have to find the range. We have to find the total time of the whole motion. So it's going to be very interesting. Let's find out what we need to do. So we see that the 2 kilogram of the block is released from this height, whereas the surface is frictionless, which is mentioned over here, and this is an angle of incline, whereas this is a height of the table that is 2 meters. And so first of all, let's find out what is the acceleration of the block. To find acceleration, we must know what is the resultant force, what is a net force for this mass which is sliding on the frictionless incline. And what we need to do for this, we have to obviously make a free body diagram, because with the help of free body diagram you will be able to know that what is a resultant force. By the way, for this inclined surface we have to assume our Cartesian coordinate system like this, in which we can assume the down on the incline to be positive, and this is our y-axis. So let's draw its free body diagram, and you can see the one force is obviously the weight that we can write mg, whereas the other force, the second and the last force, is the normal force. So this normal force is cancelled by the one component of the weight. And by the way, this is an angle of incline, the same angle that the same theta that's mentioned over here. So in the next diagram, I'm going to break down a vector into its components. For example, when I will break down mg into its components, so the adjacent with theta, this component will be mg cos of theta, and this component that is in the direction of acceleration actually is mg sine theta. That's why I'm going to erase this weight, because I have already broken it down into its components. So this mg cos theta is equal to the normal force exerted on this block. So there's no any other force, a real force, a frictional force, or any other force which is countering mg sine theta. So basically then it means that this is the unbalanced force. If it is unbalanced force, it means that this is a resultant force. So if you want to find out acceleration, I told you you have to find out the resultant force. So it means that we can say F net is equals to mg sine theta positive, and that is equals to ma. And from here we can cancel this mass and this mass, and finally a is equals to g sine theta. It means that this acceleration is constant. First of all, at all the points on the incline, this acceleration is same, so we can apply kinematics equation because this is a constant acceleration. So students, this is 4.9 meter per second square is the acceleration of this block. Okay, now let's come to the next question, that is about what is the velocity of the block as it leaves the incline. Okay, now because it's a constantly accelerated motion and we know it started from the rest, so we can say its initial velocity is 0 meter per second. So students, at this point, what is its velocity? 0 meter per second. And you know very well that this is actually the constant accelerated motion, so that's why it is covering in every next interval more distance, and it is gaining speed as it is falling with a constant acceleration. So what is the velocity at this point? To find this, we have to find first of all what is the displacement covered, right? Delta x. This is what you have to find out, and we can easily find out because the h value is 0.5 meters and the angle is 30 degrees. So you can apply trigonometry to find out that, and you know sine 30 is equals to opposite over hypotenuse, that is the displacement covered. So if you want to find the displacement covered, that should be 0 0.5 over sine 30, and that should be equals to 1 meters. So this is a velocity Vx that is unknown, and why we have to apply only this equation. Vx square is equals to initial velocity square plus 2a delta x, that's the displacement, because all the other kinematics equations require time, and we don't know how much time it will take, although we can calculate it as well. We will do it later. So if we put the values, so it should be equals to the square root of this whole. So 0 square plus 2 into 4.9. And what is a displacement? I mean, what is the final position if you assume that your reference coordinate system is here? So this is our origin, where its initial position is 0 and final position is how much? That is 1 minus 0. This is a displacement covered. So that's why the velocity will be, so that is 3.13 meter per second is the velocity of this block. All right. Okay, students, now our next question is about how far from the table that it will fall. It means that you have to find this range, the horizontal distance covered. Okay, I show you in the diagram what basically they are asking. So we know that at this point we have just calculated its velocity is 3.13 meter per second. That is its instantaneous velocity. And what will happen? It will follow this parabolic path, and how far off it is falling, that is the range. And now, in order to calculate this horizontal distance, you have already studied in the projectile motion that the only horizontal component of velocity is important, because that is responsible to take it horizontally forward. All right. So, and that will remain constant as well, because we will assume there is a no air resistance. So it means that we must find out the horizontal component of velocity uh, at this point. What is its value? Let's call it pxh. Okay. And as well as you need to find out the time. And what is the time? In order to find out the time, you must know what was the height of the table. In the question, it is given as 2 meter. All right. So if I apply the equation, kinematics equations, so what should be the, which one should be the suitable equation? So that should be delta x is equals to initial velocity times time plus 1 over 2 ax t square. All right. If you want to find out the range, this is basically the range. So I'm going to write it r, okay, is equals to the initial velocity along the x-axis horizontal times the time taken, okay, plus 1 over 2, acceleration along x-axis is 0, and the time t square. So this is an equation that we have to apply, but the problem is that you neither know this value nor this value. Let's calculate it one by one. So just imagine when the block reached at the last point of the incline plane, where you know its velocity is 3.13 meter per second. What was the angle at that point? If you see, go back in a diagram, it's a very simple. I mean, if you just geometrically, if we see, like, these alternate angles must be same. All right, which means that what are alternate angle? If this angle is 30 degrees, so then this angle must also be 30 degrees. That's why now we can find out the horizontal component of velocity, which should be 3.13 cos 30 degrees, and this one will be 3.13 sine 30, which is actually not needed now. So the range is equals to 2.71 meter per second times the time taken, Which time? The time during which this block will cover 2 meter of this distance, vertical distance. And okay, now to find this time, we have to apply kinematics equations once again. And which equation? Now this time we will apply kinematic equations for the vertical motion, because we can only find time if you assume this equation, the vertical component of initial velocity at this time plus 1 over 2 a by t square. Or okay students, so if you see in the diagram, this is a trajectory. Okay, that's a projectile motion. All right, and this was a block's initial position and this is a block's final position. All right, so if you write this equation once again, so you can say final position minus initial position is equals to the initial velocity, all right, along x-axis, along the y-axis times the t plus 1 over 2 a by t square. Okay, do you remember I told you that this one is the y component of the velocity? Okay, if we find this, now we need this. So 3.13 sine 30 degrees, so that is 1.56 meter per second. Okay, now what so conceptually does it mean? It means at this point it is 1.56 meter per second. And as the block is falling, it is gaining more and more vertical velocity. So at the end, just before hitting the ground, it's of course its vertical velocity will be more negative. Okay, you understand? So I am going to write it negative 1.56. So let's put the values in equation. What is the final position of the block? That is 0, because now it's on the ground. So that is 0 minus what was the initial position, how high it was in the start, in the beginning. I told you that it was 2 meter above, right? Because it's falling from the surface of table, all right, from the end of incline. So that should be 0 minus 2 is equal to what is the initial vertical velocity? Negative 1.56 times t plus 1 over 2 into negative 9.8 into t squared. So you see we are getting a quadratic equation. So let me write a next step. So if you rearrange it, take it on the other side. Okay, dear students, you see we have got a quadratic equation which you can solve by the quadratic formula, or you can use calculator. We will get the two values of time. So we got these two values, and obviously we will select 0.50 second. All right, approximately. Now you can find out this value of the range, how far it will hit the ground. So you remember we have made its equation by applying the kinematics equation, and what it had given us, this had given us this thing, which means that you have to multiply horizontal velocity and the time. What was the horizontal velocity? It was 2.71. All right, so let's put the values. So it should be 2.71 times 0.50. So you have to just take it half value, and the range is 1.35 meters. Okay, so that's our answer for this question. That was the question B. In fact, sorry, question C. All right. Now, let's come towards the question D. What time interval elapses between when the block is released and when it hits the floor? Okay, means that the total time. The one time that we had already calculated is the time of the trajectory, the time during which it was in the air. All right, and the time was 0.50 second. How to find the other time? You have to apply kinematics equations again, because it was moving with a constant acceleration 4.9. Okay, students, so to find the time during this motion, we can simply apply this equation. Final velocity is equals to the initial velocity along x-axis plus acceleration along x-axis times the time taken. Let's say t prime. Okay, so what was the final velocity? That is 3.13 is equals to 0 plus acceleration. You remember it was 4.9 t prime. So that will be equals to, so that is 0.636 seconds. All right. So what is the total time? And the time during this motion that we have already calculated is the t is equals to zero point 0.5 seconds. So the total time must be, we should add them. So the total time is 1.13 second is our final answer for the question. That is the question D. All right. Now, our next question, I think that should be our last question, is about, does the mass of the block affect any of the above calculation? Okay, interesting question. Well, you see, in this whole procedure, in this whole question, when we were calculating acceleration, the acceleration on incline, don't you think it is independent of the mass? It does not depend upon the mass. All right. So no matter smaller block or the larger block, okay, it will not affect its acceleration. And what about the second segment of the motion? What was its acceleration during that? Acceleration during that is negative g, because that's a free fall motion. All right, negative g. So both accelerations are not affected by the mass. So its answer should be no, it does not affect the above calculations.